All right. Hello, I'm Joe Gunn. My group members are Mackenzie, Rebecca, and Andreas. This is our project, a rural garden development in a food desert. An overview of our presentation. First is the summary of our problem, followed by a flow analysis. Then we have two different map views of our project area. After that is crop selection for the field versus high tunnel. Then we have the water usage to supply the crops. After that is water management. Then we have a fence design uh, as well as potential solutions. And then we have our next steps and the conclusion. So, summary of our problem: STAR, or South Texas Advancement Resource, is interested in developing a five acre rural garden um, in a food desert. The location is 12 miles south of Aguilares in Webb County. We need to determine the best crop selection and irrigation methods that would work for the hot and arid conditions in this area. Already on the property, there is a 1 acre storage pond that we can use for irrigation. There are also 4 high tunnels that are about 24 by 105 feet. They can be used for the crops to cultivate as well as windbreaks for the surrounding area.
I'm Mackenzie Bryant, and I will be going over the flow analysis we have for the rural garden development. The first input into the system we have is the fertilizer. The fertilizer costs around $1,900 for 48 pounds. The next input is the seeds needed to produce the crops, which cost around $70 per pound. Next, we have water as an input, which is $70 per acre foot. And the last input into our system is labor. Our outputs from the system are going to be the crops produced. There are around 12,000 to 14,000 crops grown in 1 acre. So if we are working on a 5 acre garden, we will produce 60,000 to 70,000 crops in that area. We are still working on determining the exact amount of fertilizer and seeds, as well as how many gallons of water will be used. We also know that we need a tractor and attachments for the tractor, but we are still researching on what size of tractor is needed and the exact attachments that will be best for the crops that we are growing. And then this is a overview of our flow analysis. So we have the inputs going into the system, which are the fertilizers, seeds, water, and labor. And then we have the process, which is planting, pesticides, watering, maintenance, and harvest. And then the outputs are the crops. And then once we have the crops, they will go into transportation.
All right, on this slide, we have two different views of our project area. The one on the left is a aerial view. This is good to show some of the roads as well as rivers and some of the vegetation in the area. On the right, we have the topography map of the project area. You can't really see it in the picture, but the elevations range from about 500 to 600 feet above sea level. This is good to help us determine some of the flow of water.
So when we were looking at the crops that we were going to, oh, I'm sorry, my name is Rebecca Seal. Hi, we're choosing the crops that were going to be grown in the large garden, which it's a 4.6 approximately acres. Some of the options that we were looking at first was asparagus and cantaloupe. You can see approximately how much profit we could be making for each crop. And then also some notes that we found doing some research that were taken into consideration when choosing between like For example, like asparagus is considered like a luxury item because it has higher production costs, but it produces more profit. Cantaloupe requires less water once the fruit is developing; it makes it sweeter, and but it produces less profit. And some more crops that we were deciding upon were broccoli, vining cucumber, and bell peppers. However, Aggie horticulture themselves described bell peppers as one of the most difficult vegetables to grow, despite having a pretty decent amount of profit each year. As for the high tunnel, we actually have some more freedom because it's a smaller growing area. It's easier to do some more manual labor on the items or on the crops. So, like for example, tomatoes, they need to be grown with cages because they need some support. And we'll have an easier time doing that in the high tunnels versus out in the fields. Another thing is spinach. For example, in the high tunnel, it's easier to keep it cool and it won't wilt as easy. Uh, so these are some things that we were looking at in the high tunnel. And then we were also looking at the water usage by the crops. We decided on these three were probably going to be the best for both the garden area and the high tunnels. And we have some water usage for these crops. And we also have how much they use weekly and the water, and just so we can use this to calculate later how much water we'll be using and what kind of pump we'll be using.
So I'm Marcelo, and I'm gonna talk about water management and the pump that we decided to go with. So the average stock pond is about 6 feet deep. This is from our source, Best Places, and even if it's not 6 feet deep, it's not that big of an issue, and I'll explain why. So if our pond is 6 feet deep, it should hold about 1,680,155 gallons. And this was taught to us by Dr. Kingman, and it's basically 6 feet deep by the amount of feet in an acre. And with that, we got the cubic feet and converted to gallons. Now, um, with a full pond, we should be able to irrigate for 52 weeks. We know we also have other livestock on the property, but at least for our crops, we should be able to do 52 weeks, and that's not counting like rainfall and stuff like. And since we do have like a lot of runoff that goes into the pond, I think the pond should be sufficient enough for the irrigation of the crops and maintain livestock. So the pump that we went with was a 3 horsepower pump with a capacity of 1,090 gallons, which means every week this pump would be running about 35 hours. And we checked its reviews, and it's a centrifugal pump, and it was already being used to drain ponds or like to get water to ponds. So we thought it was a really good option. It had really good ratings. Yeah, this was from Northern Tool and Equipment. Now for the fence design, this one I'd like to thank Team 3 for bringing this up, since we are producing vegetables that are like really attractive to wildlife. And one of the things that I was looking into when thinking about the fence was that Texas is an open range state, unless each county has like its own decisions to make. But Aguilares is located in Webb County, which does not have any stock loss. So basically, if any livestock goes into our garden, they're not liable for it. We decided to go with a fixed knot fence because it's not that big of a perimeter, and we thought it would be really effective. Plus, this fence from Wellscroft has a 20-year warranty, and we thought it would be appropriate for our environment, and we would also be using heavy-duty T-posts, about 7 feet tall.
Okay, so for our potential solutions, we will first utilize a drip irrigation system and a pump in the tank. These will be used to bring the water that is in the pond into the garden where we are producing our crops. Second, we are looking into introducing shading to the crops since it's a very hot area down there. The crops need shade to be able to produce. Third, we may forego this and water the crops enough without sun protection. The shadings might be very costly, so if they're not financially worth it, then we may just have to do it ourselves and go without the shading. And then the last thing is we will utilize the tunnels, and then these tunnels can also be used for the shading of the crops. The elevated small crops will protect them from the small animals, and the vine crops will be planted on the ground. And then this will also reduce the amount of pesticides needed since it is in a controlled environment.
So going forward with our project, we will need to meet with Mr. Rainey to check our progress on this project, making sure we're going towards the right goal. We also need to meet with our faculty advisor, Mr. Stark, just to, I guess, aid in our project and help with some of the analysis that we have coming up. And we also need to create a decision matrix to compare solutions to determine what might be the best one. And that is the end. Thanks for your time. Are there any questions, comments, or concerns?
Okay, Mr. Rainey, go ahead.
Yeah, I had a question about the fertilizer cost that you had at the very beginning. Seems like there was a math error there. I'm fairly certain I can go to Home Depot and buy a 48-pound bag of fertilizer for about $19. So is it 48 pounds per so many feet, or how'd y'all get that number?
I looked it up and that's what I found, but now I'm looking it up and it's saying 470 per ton. So we just need to go over that and figure out that we have the correct information.
Okay. Yeah, it just looked really high. Other than that, the presentation you're coming along is doing, you're working toward a solution. You got all your stuff kind of working. I thought it was okay. Thanks.
Okay, team 3, y'all want to make your comments, questions?
I like how they go through the presentation, they have numbers. You have to speak up a little bit.
Yeah, you're gonna have to overcome that big old mask.
Yeah. I like how they have numbers and how much water can be used in it, and also for gallons where they've already stated and show how it's organized for each crop, where say broccoli takes this much for so on and so forth, and then the yield they'll get per acre.
Okay, anybody else?
Yeah, I would recall it. I mean, like how they had everything quantified.
You're gonna have to speak to the microphone.
I thought everything was very well quantified and the numbers were very clear and everything was very easy to read.
Good. Anybody else?
I couldn't hear him too well.
Okay. Why don't y'all step up here closer to the microphone? We're really pushing the limits of our technology.
One of the things that I noticed in my presentation last time was that I wish that I had more enthusiasm. I think Joe might be able to work on that a little bit, have more enthusiasm. Rebecca did a good job of that, I thought, but you did use some hand gestures there. I think if you're going to be on Zoom, you use hand gestures, either move away from the camera where you can see like what you're doing, or just don't use hand gestures at all. I mean, I could be wrong, but that's just something that I thought of.
Good comments.
It seems to me that some of the information was read off just directly from the slide instead of Not reading off the slide, making it short, a little bit shorter, and explaining more about it instead of just reading what's stated on the slide.
Okay, good. Dr. Castell, do you want to go next?
Yeah, I like the flow and the distribution of the speaker's time. It was well balanced and it moved from one speaker to the next, so that's good. I like the numbers in the flow analysis. Seems like you have done some search trying to find amounts that will help you with your decision matrix. I like the analysis of the different crops and why you're kind of leaning towards broccoli and tomatoes and cucumbers. So that was good. Talk about which one we make profit, which one wouldn't. Just keep in mind which one will be a good vegetable in their nutrition, right? It's gonna be sold for people to address that too. I like the use of photos of the area, and that always helps to see what you're talking about. In your flow analysis, your flow chart is good, but again, it has no numbers, so you could have used that slide better. Yeah, and again, the toys out there, even though you explained it before, it would have been nice to see some ranges of numbers, quantities, how much you need to input. So the major transportation step, I was waiting to hear where is this going to be transported to? Local stores, farm market? I don't know. So I had a question about your flow analysis chart because there wasn't enough said about it. Otherwise, yeah, good flow, good distribution. Your slides are clean and easy to read. So good job.
Okay, yeah, your presentation was 12 minutes long. That was good use of time. Your potential solutions have the same problem as the previous team. You don't have three separate standalone solutions. There's not one potential solution that is fully developed that can be chosen as the recommended solution. You've got components but you'll need to integrate them into separate solutions that can be analyzed. I tell you, my favorite part of this presentation is when water usage, the water usage slide. Is that Rebecca's or
yes.
Okay, right there. There are some numbers that we're looking for. Here you're telling me that broccoli requires this much water. That's good analysis. And now you need to take that to the next level and use this information to figure out which are going to be the optimum crops to choose. Marcelo had a good slide too. Go to water management slide, couple down there. I love that slide. You even tipped your hat to another class you had, so you integrated course material. Okay, well done. That's what we're looking for in this class. You presented it well. Maybe instead of a picture of the pump, you could have actually drawn a cross section of the pond and shown a little bit more of how you came up with that. Now, I'm not sure I buy that you're really going to have 150 million gallons of water available a year, but you know what? At least you did the analysis. So that's really that's good. That's what we're looking for. Go to the next slide. It's design. Okay, here my question is, if I was the client, what are the major threats to my system that I'm trying to fence out? So before I spend all the money on a fence, and the welded wire fence is kind of expensive, especially depending on how high it's going to be. What am I trying to keep out? Raccoons or deer? I mean, the fences for those two are going to be very different. What's the biggest threat?
I would think mostly deer species like that and livestock, the bigger animals.
Okay, here's my problem with your answer. You said I would think. What I want to hear is, well, we've done some research and we've determined, okay, that here's the biggest predator or to problem in the area, and so this is the type of fence we need to keep that out. So do you have an answer like that? What are you trying to fence out?
I actually
kinda
did
do.
the research. I found that in South Texas, there is wild deer, you're going to have jackrabbits, and in some rare cases, ocelots and javelinas.
Okay, so you've got a pretty big variety. Which one is going to be the most, going to give you the most damage in your system? I mean, you could build you could try to fence them all out. That's going to be expensive. Which one do you think you need to keep out the most?
The deer.
Okay, so that's going to drive a certain type of fence. You see what I mean? So the flow analysis should drive what you do in your solution. But still, y'all are you're thinking in the right direction. Bill, did you have a comment?
Yeah, the feral hogs generally are going to be a problem.
Okay.
That's something.
So use your client as a resource too. You know, you can ask him, what do you want to keep out? And if he wants to keep out feral hogs, well, that's going to be a different type of fence, and the cost is going to affect the cost. Let me go to, there was a question I have on one of Mackenzie's slides. It had to do with outputs. Right here, I don't understand this last bullet. There are around 12 to 14,000 crops grown in an acre. What is that?
I was looking it up, and it says about 12,000 to 14,000 plants can be grown within an acre of the crops we were growing. So I was looking up asparagus, like how much asparagus can be grown in an acre, and that's the numbers that were given to me.
So what you mean is plants instead of crops, right?
Yes, sorry.
Okay. Yeah, that really confused me. That blew my mind when I saw that. So there'll be around 60 to 70,000 asparagus plants grown.
Yes.
Okay. Well, it's not clear that you're talking about individual plants. It's not clear what you're talking in terms of asparagus. So this is the slide's a little unclear. You know, there are other comments I could make, but the main thing the order of the presentation. I thought it was a little odd that where the aerial photograph appeared in the presentation, because Joe did the introduction and did some talking, and then Mackenzie did some flow analysis, and then it jumped back to Joe for the aerial. You know, Joe, why didn't you just go ahead and put the aerial topography in your first part of the presentation so there wouldn't be so much back and forth?
He led with the flow analysis just because that's the section of the report we were on, but I do agree that it would look better before that.
Okay.
We actually considered doing it that way, and it felt like the flow came like too late in the presentation, and so that's why we switched it. But I understand what you mean. So. Okay.
Not a big deal. I was just curious. That would have been a way you could have cleaned it up a little bit. Okay. This is the comment I'm going to make to both the teams, and I'm repeating this comment from last time. Linear program. Okay. This is the Bradley farm where you're trying to choose which crops to plant in a given acreage, and each crop has its own constraints in terms of cost and water usage. There are a couple of constraints equations you can come up with, and each crop that you might select is going to have its own profit coefficient. So how much of each crop should the Bradley family, or in this case, Mr. Rainey, choose to plant in their acreage? This is using a linear program would be an excellent way to demonstrate to your client that you're optimizing the resources and going to maximize its profit. Okay, so I sure would like to see somebody do that. I will help you write it if you come see me. Okay, you've got to have the data, the profit coefficients, and how much water they use and what it costs to plant them. But we can write that linear program. If you do that, I can't imagine giving you anything less than an A in this class. Okay, so the challenge issue. Any other comments, Jan?
I do have a comment. For both things. So I'm from the engineering department. I'm not familiar with the management analysis. But can you go to your flow analysis, the chart? So I see 4 inputs and outputs, 1 output. But what's the units you want? I mean, the final output you want to analyze? Like it's a money or yield or water usage.
Sorry, what was the question? I couldn't really hear it.
Let me see if I can, I think I understand what you're asking here. So this chart has, it's a good concept chart, but it's kind of lacking in specifics. Yeah, and I'm not sure it really tells us anything we don't know. We put in fertilizer, seeds, water, and labor in these processes to grow a crop, and then we transport them. Okay, yeah, I got that. But what we really need are some numbers. How much fertilizer, how many seeds, how much water, how much labor, how much time goes into the process or whatever, energy. And then crops, what would the yield be in terms of maybe pounds per acre or dollars per acre, that kind of thing. So you could really add a lot to this slide by trying to quantify this, I think is what you're trying to say.
Yeah, and then that's something I'm still working on to put in the flow analysis due Monday is the exact numbers we need and everything. So for the progress report, I was just kind of doing an overview of what we had, but I do know that we need to determine the specific amount of each thing we're going to have.
Okay, and you know what, Mackenzie, don't be too worried about the exact numbers. Estimates are fine. Okay, they need to be informed, not guesses, but it's going to be tough to nail down the exact numbers. Okay, so do the best you can with estimates, just to give the client an idea of quantifying what he needs to do. And that's another. My last comment is probably on Rebecca's slides about asparagus and tomatoes. There was a lot of qualitative terms. This is going to use more water. This is going to have less profit. If I'm the client, I'm going to go, well, tell me what does low weekly water requirements mean? Noted is one of the most difficult vegetables to grow. Tell me why. Is it because of temperature, or is it because of pests, or is it because of water? So I'm really wanting to see more quantitative terms instead of low weekly water requirements, which is a qualitative statement. Weekly water requirements is 1.5 inches per acre per week, something like that. Something with a quantitative answer.